Hello and welcome back. Today we will talk about the ACME protocol, which will help us to get certificate. And most of the providers, especially Let's Encrypt, which is the pioneer of using this protocol, totally free. So if you need a certificate to make your services more secure, including HTTPS, but actually any other kind of TLS-based certificate, you can just request it from Let's Encrypt or from a few other providers. But what we would like to do today is just get a better understanding how does it work under the hood, because there are a bunch of good high-level tools to actually get the certificate. So actually I believe that the hard way is the easy way to understand something. If we do it manually and check all the details, then maybe our understanding can be improved. So let's start. First of all, we need a key. So it's from this point of view, it's similar to Bitcoin or Ethereum. That our identity is our keys. So I don't need to register something, or some providers may require it, but for Let's Encrypt, it's enough to create a key and sign all the requests with the same key. So I just generated my keys. You can see that this is pretty standard OpenSSH key generation. I also generated the public key in PEM format, and I used this utility to use a JSON format for the same. So this public key is exactly the same. It just because the protocol itself uses JWS, which is the JSON Web Signature standard. So we need the public key in this format. And the other thing what we need is just a URL. So in this demo, I will use this staging or demo endpoint of the Let's Encrypt. And if I call this endpoint without any magic, I will get this directory, which means that it will return with all of the endpoints what I can use and a few other metadata, including the terms of service. So I need a new account, right? I have the private key. That's my identity. So let's post something to Let's Encrypt that, okay, please create a user for me. So we need JWS signed requests, which is slightly more complicated, but it's only slightly. So I have a helper. I extracted most of the part from acme.sh, which is a high-level tool, and it's way more complicated, but very powerful. So what we will do at the end of the day is just sending a request with application with this content type, and we need a JSON file with 3 main fields. So the payload is the exact payload what we would like to send. The protected is some metadata that who will sign the signature. And the signature is just the raw signature. That's all, and we can send it with HTTP. So the payload and protected is very easy. We just encode the request and protected that we will JSON files, we will generate them with some scripts. So the encode is just basic URL, basic base64 encoding with some special rules. So base64 URL encoding, and the signature calculation, it's complicated, but it's still simple. We need to concatenate the protected and payload, and after that we will just sign it with this utility. The only problem is that this utility, this OpenSSL utility, returns the signature in a different format. So first we will convert the format to this, and after that we will grab the required part, the 2 numbers what we need here, padding, and after that we can generate the signature in our format what we would prefer. This is converting back to binary from hex, and after that base64 encoding again, and it just added as a field. So we are ready to go. The request is very easy. It just I agree. The metadata is actually just my public key. So this is the JSON version of this one. This one is the URL what I use, so I include the URL in the package which will be signed, the algorithm what we use, and the nonce, which is a Unix thingy. Usually it can be used from the previous request, it's in the header, but I just get a new one every time with using one of the endpoints and grabbing the nonce just to make it easier. So, ready to go. Yes, and now I have an account. And actually I have an account identifier. This is the identifier. So if I send something to Let's Encrypt and saying that I'm this user and I'm using the same key, so I'm just signing the message with the same key, then Let's Encrypt will know that, okay, I already accepted the terms of condition. This is my user. So let's go forward and request a certificate for my domain. Now the protected part, it's more easy actually, because I have the user identifier. I don't need to send the public keys because the public key is already there. I still have, this is the user identifier, this is the URL, nonce, algorithm. So from now, everything is more simple for the protected. This is what we will use in the next request. The request is a simple JSON, but I need a domain, something like this. And now I can send the signed request to the URL. And it's pending, so I have 1 week to somehow prove that I own this domain. So there are multiple ways to do this. So if I go to the challenge, I can just curl this part. And you can see that there are multiple challenges available, the HTTP, the DNS. Anyway, somehow I should prove that this domain is my domain. I would prefer the DNS. It requires some DNS changing, but I wouldn't like to open the HTTP 80 or the TLS ports. They are predefined rules that which port should be used, but I wouldn't like to. So let's go with the DNS. So this is a token. The DNS-based challenge means that I should prove the ownership with putting this some specific unique information to the DNS record. Not this unique information, but this information. So actually this information is just a SHA 256 and encoded version of a string, which is the token. So actually this is what we just digested. And the first part of this one, this part, is given by the challenge. So it says that, okay, this is the challenge. The second part is this thumb, which is nothing more, just the digested version of my public key. So this response includes my public key. So this should be SHA 256 encoded and base 64 encoded, and that's the second part. And all together, so it's just more safe because it's special token just for me. So I have this TXT token, and I should prove that it's mine. So what I will do is just check my DNS server. So I have a DNS server here, and this is core DNS, so it's very simple and pluggable. And it says that storage node top zone is served from this file. So I should check the zone file itself. This is a pretty standard zone. So this is just generic. It says that these are the name servers, these are answers for the name server queries, these are answers for the A queries, the IP address, and this is what I should modify, because this is the convention that, okay, this is the domain, so this one and this one together, right, because in this zone, and I need to add this prefix, and the prefix is the version of the domain. or some domain should have a txt record. So I'm just go back. I'm regenerated the config map here, which includes both the files, and I will deploy it soon. It's configured, and I need to restart the pod itself. And now I can try it out. So let's ask the first name server about the txt entry, and this is the full domain name which should be used to prove. And it's there. Just let me double check if we have the right content. So ODT. So we have the fresh proof deployed. So now we can go back and ping. Let's encrypt that, please. Test it as well, because I would like to create the CSR. So please double check the DNS. I proved it. So request is actually, it's a empty JSON, not an empty string, empty JSON, because I'm just pinging. So protected, it's the same as before. I don't need it's just the account identifier and the URLs. And the URL what I use is the challenge URL. So I got it from this response. So I had here, and this is where I started in this. This is where we have the challenges. So I can just post a signed request to the challenge. Okay, and I posted it. So that's Encrypt said, I know I can be checked. Please give me a few seconds, because I will surely do. Okay, this is pending, so I will check again the challenge URL. And you see that previously it included all the possible ways to prove. Now it says that it's valid. Yes, it means that finally we put the right string to the right place. So now I have the power to create the actual certificate. Now it's nothing more, it's just until now we just proved that we have the host name. So let's go to here, and we will generate a certificate request. So which means that we need a private key. This is for the web server or HTTPS server. This is not for the Let's Encrypt account. And we can just do a self-signed certificate. So let's generate, and doesn't matter, this matters. So the only important that it should use exactly the same domain name. All the others are not very important. And now I have the certificate signing request. So the request will include the certificate signing request. Again, I just converted it to a slightly different encoding just to follow the standards. And we can also check what's inside. So if I do this one, you see that this is a request, this is a certificate request, and I will just output in a txt form. So certificate is nothing more, just a public key plus metadata in a signed form. This is my metadata, this is my public key, and this is the signature. This is still a self-signed certificate. That's what I would like to replace. So let's just request a new one. Okay, so processing. Well, it means that, okay, I will create the certificate. It's just a few minutes. So let's go to here. I don't need to send signed requests anymore, because the only thing what I should do is download this stuff. So in the very first response, I had a location header. which is the URL of the order. And if I check the URL of the order, that was the authorization URL what we used, and this finalize is used to submit the certificate request what we used in the previous step, and this is finally available, the certificate itself. So I can just download the certificate. I'm just saved it in a file and we can check it. So now it's not one certificate, but two certificates, right? The first one is supposed to be my certificate, which means that it should be yes, this is my subject, my metadata. Well, a few other metadata is added, so the validity and my metadata, my public key, signed by Let's Encrypt. This is the issuer, so additional metadata and the signature. But to check this signature, we also need the public key of this signer. So that's why we have the second certificate as usually in HTTPS, which means that the metadata and the public key of Let's Encrypt is there and it's also signed. But finally, this signature can be checked because this is signed by a root certificate authority, which is somewhere hard-coded in my operating system. So I will just accept it and I will believe that it's fine. So, and that's all. We have the certificate. This certificate, together with the private key, what we generated for the certificate signing request, can be used in any HTTP server to make it more safe.